go ahead and get started. First, the good news. I don't have your exams finished yet. I've got them partly graded. That's also the bad news. I anticipate I'll get those done tonight. If not, then Tuesday morning, tomorrow morning. And I'll post scores and have the exams for you to pick up on Wednesday. Or in lab, of course. How much fun did you have for the Super Bowl? Lane? Yeah, I didn't want. I'm not a football fan, so I don't know anything about it. Count your lucky stars, though. I don't know if I mentioned it before, but usually the first midterm exam falls on Super Bowl Monday, and students hate that. But this year we got lucky because of the early start. So today we're going to talk about green phototrophic bacteria. There are three kinds of green phototrophic bacteria, and they're not phylogenetically related. There's an interesting relationship between the phototrophy and these organisms. There are the green non-sulfur bacteria, often called the chloroflexi, the green sulfur bacteria, or chlorobi, which are generally related to Bacteroides, and there are the cyanobacteria, or blue-green algae. These things contain bacterial chlorophylls, except for one small phylogenetic group within the cyanobacteria that have traditional chlorophyll, the same kind of chlorophyll that plants have in their chloroplasts. They contain a variety of them, A, B, C, D, or E. These chlorophylls give them a green color, which is very often heavily modified by accessory pigments, things like retinols and so forth. Many of these, the green non-sulfur bacteria and cyanobacteria are very often have lots and lots of red accessory pigments, and so they end up being kind of a rusty brown or golden color. Green sulfur bacteria are usually really green. Now, if you're going to absorb light, you need to have lots of membrane, because that's where the absorption of light comes from. And so these organisms use different mechanisms for increasing their membrane content. And we'll talk about how those are different for each one. In all of these organisms, these internal membranous structures contain the antenna complex, or antenna pigments. But the photoreaction centers are in the cell membrane. That's different than chloroplasts, right? We're also going to talk next week, or Wednesday, about the purple bacteria that have A and B and have antenna complexes in a different setup. Let's see.